And let me just share my screen for a second. Okay, here it is. And well, I'm just trying to move my screen so I can also hear this. So yeah, my name is Javier. I'm a developer advocate in Spain. And yeah, that means that I basically, AWS is paying my salary, but I work for the community really, because what I do is just engaging with technical audiences like yourself to tell you what you can do with AWS, what's the best way of building your applications on top of it, and also to get any feedback. So if you have any feedback at all about the tools I'm going to be talking about today, I will be more than happy if you could just share on the chat, so so I can know a bit better which are your experiences with these tools, so we can improve the services for all of you. And today I'm going to be speaking about how you can build a data lake in the cloud. And if you have any questions, I believe we have a few minutes after the talk to for the Q&A, but feel free to also ask me on Twitter if you want, and if I don't know the answer, I'll find someone that can help you. So first things first, if at any point you have any question at all, I'm more than happy for you also to interrupt me. So feel free to open your microphone and just ask me, or if you want, ask in the chat. I'm going to keep an eye on the chat during the session, so you can wait until the end, but you can also interrupt me. And I'm sure if you interrupt, it will be better for everyone, because when I speak, it tends to be very boring, but when people ask, things are more interesting. So with that, we're going to be starting. And I don't know if, your profile, I don't know if you are more developers, or if any of you have already any experience doing data analytics or working with data engineering. If you have any experience working with data engineering or analytics, you can also tell me in the chat, so I know you a bit better. But just in case, before I tell you how to build a data lake, I'm going to tell you a little bit the history of doing data analytics for the past few years, or at least the history, the way I moved from being a web developer to work mostly on data analytics. So a few years ago, or actually a long time ago, I used to do mostly web development. My analytics problem were fairly simple. I would have to run reports out of my database, but if I had a few thousand users, generating a report for each user would slow down my database. But that was pretty simple stuff. But then I realized that there was a lot of data that was not really living on my database, but it was very interesting for running analytics. For example, the click streams of the users on a website, or the screen flow of the users on a mobile application, or the log files, or a lot of data that was not structured and that I couldn't really fit on a traditional database. And for that, we had something new at the time that was called Hadoop, and Hadoop will be something that will allow every developer to run analytics at any scale using Java, okay, but you could run analytics at any scale with Hadoop. But then things got more interesting, because it was not only about working with unstructured data that was very large. It was also about data that was moving very fast, because we started seeing mobile applications, we started seeing Internet of Things, we started seeing more broadband speed everywhere. So it got to a point in which there was a lot of data moving faster than ever. And the current state of the things, the traditional databases, the traditional environments for doing big data were not really prepared for data that was writing faster than you were reading. Because in a traditional world, you usually write to the database a few times, and then you are reading most of the time. But on big data, it was the other way around. We're getting data very fast, and and you wouldn't need to read data all the time, only once in a while. And we started seeing things like Kafka or RabbitMQ or different message systems. And then we started seeing more interesting problems, like the more data I had and the more the ecosystem evolved, I wanted to do more interesting things, like getting insights in real time. Or the moment I had a lot of data, I was starting to get lost at how to have an inventory or a catalog of the data, and it was very difficult to keep track of the changes. And I wanted to do, of course, analytics not only with Java, but also with other languages. And new tools came, tools like Spark that will allow you to do streaming analytics and batch analytics with a single component. We started doing more complex ETL scenarios. We started thinking about new problems that we didn't have in the past, like data governance and data quality and all those things. Of course, data security. And we came to the state in which we are today, in which basically we are still, of course, doing data, which is structured and unstructured, which can be slow or can be fast. And we want to keep adding new things. Like, for example, lately, we've been adding a lot of machine learning to the analytics. So that's kind of the problem we are trying to solve today. We want to have a platform in which I can work with data at any scale, of any type, at any speed, to do any type of processing I want to do, that I can add new functionalities in case I want to, to use a new technology like machine learning today or Internet of Things or whatever I want to add to my stack. And I want to be able to, to evolve my schema, have data governance, and all those things. So how you do this? Well, if you've been around analytics for, the past few years, you might have heard the term a data lake. And a data lake, it's in the most simple definition, would be a place, a repository, in which you put all the data that you want to analyze in the organization. And that might be structured data, unstructured data. It might be, I don't know, files, it might be emails, it might be images, it might be data on your database at any scale. But if you want to have like a really, really powerful data lake, it's not enough just to have a repository of the data. You need to have some way in which the end users, the business users, can query the data directly without having to go to the data engineering department. When I was starting in data engineering, every time the business wanted to create a new report, they would have to come to us and we would have to create a new report from scratch, spend a lot of time. It was really not useful. So you want to enable interactive analytics so users can query the data lake without you having to be in the middle. And also you want to enable the possibility of adding new components in the future. That's kind of the thing what we're going to be building today. And by the way, it's not going to be just me speaking. I have also a demo in which we are going to see how to build a data lake. So just bear with me here for a few moments. So the good news is, if you want to build something like this and you want to do it with open source, you can do it, and it's very easy. All you have to do is you have to install these components, and you're going to have a perfect data lake. You're going to have a data lake that can deal with structured data, with unstructured data, with machine learning, with monitoring, with permissions, with a dashboard for business insights. You're going to be able to query data with SQL or with your favorite programming language. You're going to be able to do data science. You're going to be able to provision everything automatically using infrastructure as code. So if you install all these open source components, they're going to have a perfect data lake. But I don't know you, but when I see this screen, it's like, here, this sounds a bit too much, and it is. In the past, I've used all of these components in production, and it takes a while to get used to them. It takes a while to learn what they do, and it's very fragile because once you have, imagine installing all of these things, configuring security, configuring everything so for the components to play together. So the moment you finish your cluster, you don't want to touch anything, because the moment you upgrade one component, you might be breaking the others. And it's quite hard actually to maintain these things. So you're going to be spending a lot of time in operations instead of really spending time on dealing with analytics, on dealing with the core of your business. So that's kind of the problem. If you try to do everything, just managing it on your own, you're going to have a very good solution, but it's going to take really a long time of your operations team to have things up and running. And of course, there is a smarter or a more efficient solution, which could be using cloud services. So if you use some services on AWS, you can have the same analytics, just relying on AWS for many things. For example, if you are managing infrastructure on your own and you have a server and the hard drive for the server is getting full, well, of course, you need to add more disk capacity, but you don't really need to have an engineer for doing that. You can easily automate those things. Same thing if you have a machine and the machine goes down. Yeah, you need to start the machine. Or if it broke, you need to replace it with a new one. But again, you don't need an engineer to be taking care of that. So there are many things, same thing for networking, for scalability, for backups, for security. There are many things that you can automate easily and that are not unique to your business. They don't differentiate what they do. They are exactly the same for your startup or for a large company than it's for everybody else. The thing that makes your business different is the business logic, is what you are doing, which is unique. So if you are spending time dealing with hardware, dealing with configuration, dealing with low-level security, all those things, you probably are not focusing on what's more important for your business. So the cool thing about AWS is we are going to be offering you solutions at different levels. Some of the solutions that we offer you for data analytics are based in open source. So if you like the previous slide in which you have a lot of open source components, many of them, you can just run them as managed services on AWS, meaning that you can do exactly the same you were doing with your open source solution, but we take care of the versions, upgrades, security patches, hardware, and so on. Some of the services are not open source, but are based on open standards. So it's very easy to move in and out of those services. And some services are native services on AWS. So depending what you want to do, we're going to be covering different services that you can use for doing your analytics. So that's the first thing. And of course, AWS is a good place to run your analytics, because you might be asking, okay, Javier, but if I choose AWS for my data analytics, is it going to be powerful enough? Well, we have more customers than anyone else running data analytics on AWS because it really works. I'll tell you later about an interesting use case of one large customer of our analytics stack. And this is boring, but it's important. So when it comes to security, everything using AWS, we have access to exactly the same security tools that we offer to every other customer. So the same tools that you have for, I don't know, for banks or for airlines or for government agencies or for large and small startups, the same security tools, exactly the same, are available for every customer. And if you need to meet any regulatory standards, because you are in a regulated market, we are compliant with many different regulation frameworks, and we keep adding them, when customers are asking to support some new. So you can be safe running your workloads on AWS. So the first thing is, okay, imagine you want to build a data lake in the cloud. The first step is, how do I move my data from wherever I have it to AWS? If you are starting from scratch, it's very simple because you don't have any data, so you can start just using AWS services and that's it. But imagine you are already working, you have been already working on your own data center, and you have many terabytes, maybe petabytes of data, and you want to move to the cloud. There are many different options to moving your data between the outside world and AWS. But rather than boring you with different options, I prefer to do this question. So what is the largest hard drive you have ever seen? So largest hard drive. Let me know in the chat. Largest hard drive you have ever seen. Come on, any takers? No one? Cool. Couple of terabytes. That's actually quite big. Couple of terabytes. It's a nice hard drive. So, oh, by the way, someone is asking me if I'm going to be sharing the presentation slides. Yeah, I'm going to be sharing the presentation slides, of course, and the meeting is being recorded. Oh yeah, someone is saying 4 terabytes for personal usage. That's a large hard drive. So this is the largest hard drive I have ever seen. You see that? So that's not a trailer. Well, actually it is, but that's actually a hard drive, or an array of hard drives. So that's called the Snowmobile. And the Snowmobile can have up to 100 petabytes of data. So that's 100 petabytes of data. Sorry, I'm just writing that on the chat. So that's what you have on that hard drive. So imagine you have a large company and you are doing scientific research, or you are taking satellite imagery, and you have lots of data and you want to move to the cloud, but it's like, how am I going to move that data? I cannot move it over the network. Yeah, you cannot, but you can call us. It's like, hey, Amazon, yeah, I would like the Snowmobile. That's okay. We drive the Snowmobile to your data center. The Snowmobile comes with 2 kilometers, or I believe it's, I'm not sure if it's 2 kilometers or 2 miles, but yeah, 2 kilometers of cable. So you connect directly the cable to your data center, and you can start copying data locally. And in about 1 week, if your network is fast enough, you can fill the whole trailer. So it's about 1 week to fill all the data. Then we drive the trailer to the closest region on AWS. We connect the trailer to our data center, and we offload all the data to S3. So basically, in about 2 weeks, you can move a whole data center 100 petabytes. If you want to move a larger amount, we actually can send you several Snowmobiles in parallel. So this, of course, is not something that we are, this is not something that we usually see a lot of customers adopting. It's only for large customers. We have smaller solutions that we can send, not only the Snowmobile, but this is for you to see that if we are able to deal with this scale, we're actually able to move your data, no matter who you are, to AWS. So once you move the data to AWS, the next thing is, okay, but where I'm going to be storing the data? And this is the AWS user group. So I'm guessing all of you know about S3. S3 is very efficient. S3, you only pay for what you use. You can store as much data as you want, and it scales, without any complication. You can also have different strategies to have different tiers, depending how frequently you access the data, to pay less using, things like Glacier and so on. So basically, you can use S3 to store as much data as you want. And one thing we did with S3 a few years ago, we add support for this thing here, something called query in place. And I found that sometimes developers don't know about this. So query in place is the possibility to select only parts of a file on S3. As you know, on S3, you pay for how much data you are reading and writing, but how much data you are reading from S3. So if you want to do a big data query and you need to download the whole file to do the query, it's not really efficient, because on big data, you usually have, imagine you have a database for analytics on a business. It's very common to have, I don't know, maybe 50, 60, 70 columns on a database for analytics. And out of these 60 columns, you are only interested in 2 or 3. Like, for example, give me the total number of orders per country by date. So out of all the columns, you are going to focus on only 4 or 5 for a particular query. If you are using S3 in the traditional way, you will need to download all the data, then to filter pretty much everything. That wouldn't be efficient in performance or in money. So query in place allows you, when you run, if you want to run that SQL query on S3, you can download individual columns. So it's much, much more efficient, also in cost. So S3, you already know, is quite interesting. And when I talked before, okay, so S3 here will be the center of the cloud solution for analytics. And around S3, we have a number of services. Actually, there are more services than I have in this slide. We have a number of services we can use for analytics. And this looks nice. But if you remember earlier, I showed you this slide, which is quite ugly, the one about open source. And I told you, with open source, it's very difficult to build your solution because you have to keep track of many different configurations. But if you notice, what I did here was just put in this slide, which is very ugly, with a lot of text. And then I put this with AWS, which is, it has colors. But if you notice, I have many different services here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 20, I don't know. I have over 20 different services here. So if you want to use them all, and if you want to integrate them all without some easier integration, it will also be very challenging to build a data analytics solution on AWS, because you will need to configure each service individually, and it will be difficult to keep track of security, to keep track of connectivity, to keep track of permissions, to keep track of monitoring, and all those things. So until 3 or 4 years ago, that was the situation on AWS. You will need to configure each service individually, which was not really the best option. But a couple of years ago, we released something called Lake Formation. And Lake Formation is a solution we offer in which you can centralize all the data lake connectivity in a single place. So instead of having to deal individually with each of the services that are going to be reading data from the data lake, you only put the data on S3, you configure permissions, access, management, policies directly on the lake formation. And whenever you want to use any other service to query data from the data lake, that service is going to speak directly with lake formation, so you don't have to worry about anything. So we give you a way in which you can still use many different services for doing analytics, but you don't have to worry about configuring each service individually, which makes your life much easier and also allows you to combine different tools depending on the type of analytics you want to do. Okay, so since this is a bit weird, before I move further, before I tell you more how this works, what I thought would be interesting would be directly do a demo of how this works, and then I'll tell you a couple more things. So let me just move here my browser, and I'm going to be opening, just a second, this is the one. So there is an open data set, a public data set, which is by the New York Taxi and Limousine Commission. And this is the agency that coordinates all the taxis in New York City. And since a few years, they've been exposing all the taxi rides data as an open data set. So this open data set, for each month, you get a CSV file. Actually, you get several CSV files because they have different type of taxis. I'm going to focus only on the yellow taxis, but for each month, you are getting a CSV with all the information of the taxi rides. So for example, here, if I go to 2018, I will have 12 files for each of the, each of the dates. And the good thing is that this data set is actually hosted on AWS. If I go to the AWS Open Data Registry, it turns out we are, let me just search for this, taxi. This data set is available directly on S3. So it's available here on this bucket on S3 if I want to connect to the whole data set. So something I did on my account for this demo, I went to my account, I went to S3, still getting used to the new interface. Okay, so I went to S3 and I created a bucket. Let me see what it is. Here it is. And on this bucket, I copied all the data for the year 2018. So here I have one CSV for each month, and each CSV is about 700 megabytes. So in total, this is slightly over 8 gigabytes of data. So I'm going to create a data lake. My starting point is going to be 8 gigabytes of data of CSV. So imagine your boss tells you, your manager tells you, I want you to analyze 8 gigabytes of data on CSV. It sounds boring, yeah? It says it's too large files. It's going to take a while to make sense of the data. So the way you can do this on AWS is like this. You go to Lake Formation, and you tell Lake Formation that you don't want to analyze the data. You want AWS to analyze the data. So I'm going to tell Lake Formation, to start crawling data. Crawling means query data from an external source and make sense of the data. So I'm going to be creating a crawler that I'm going to call 00 Colombo, for example. I'm going to be telling my crawler, I want to catalog data that I have on the bucket I just showed you. So demos glue, here it is. New York City, yellow year. So this is the data I just showed you. I'm just going to that bucket. I could be adding more sources. I could be adding data from streaming sources. I could be adding data from a different bucket at the same time. I could be adding data from SQL databases, but I don't worry about that right now. I only want to start with this data set. Of course, as you know, I have to choose a role. I already have a role with permissions. I'm going to be using that one. And I could schedule this to run periodically, but I'm going to say I want to run on demand. And I need to choose a database in which to store this data. A database is no more and no less than it's just a way to group data together, to catalog data. So we are not really copying any data, we are just cataloging the data. So when I was doing the demo today, I created an empty database called Colombo. So that's the one I'm going to be using. And with this, I created a crawler. And now I'm going to tell this crawler to start running. So this is going to take a little bit, and I'm going to tell you what it's doing. So right now, this crawler is going to my S3 bucket. And on my S3 bucket, it's going to check the structure of each of the files. If all of the files have the same structure, so in this case it's CSV, if they all have the same number of columns and the same types and the same headings, it's going to catalog all the files as one single table. If it detected different type of files, it will create different, it will catalog them as different tables. But it's not really moving any data. It's not duplicating any data. It's just cataloging the data, just saying, okay, in this bucket, I have this data with this structure. So that's basically what we are doing right now. And as you see here, after 35 seconds, it says that one table was added. I'm going to go to my database and I'm going to check if that's true. So I have here one table, okay, which lives in this location. And this is the schema that was discovered. So this is the schema that was discovered on the CSV. I only have one table because all of the files have the same structure. And this is the data I have. And something I don't like, for example, here, I don't like that the dates are going to be cataloged as strings. Strings are not really useful when I want to do operations. I prefer them to be a date time. So I'm going to change that. Let me just say the schema A. You auto-discover this is a string because it's actually a string, but I want to convert, I want to use it actually as a timestamp so I can do more interesting analytics later. Cool, so I can do that. I can save my schema. And here, of course, every time I change the schema manually, or if the schema change on S3 when I have new data, all the history of the schema is going to be here. I'm going to be able to see all the data. So now, once I have the table created, I want to work with the data. So the data is living on S3, and if I click here on View Data, what would you expect to see? I remind you, this is 12 files, 12 CSVs, about 8 GB of data in total, and I'm going to click on View Data. You might be expecting to see just a spreadsheet because this is a CSV. But if I click on View Data, it is more interesting because what I'm getting actually, when I click on View Data, is that I can run queries, I can run SQL queries directly on top of my data on S3. So once I catalog the data, I can directly start running queries with Athena. In this case, I'm saying, okay, tell me just this is the table that I just saw, and I can do things like give me the count, for example, of how many records I have on these files. And I have only 100 and almost 3 million records on the data set, because that's the whole number of taxi rides that we had in New York for the yellow taxis in the year 2018. So I could do any kind of query. I could do things like, for example, I want to know which are the how many taxi rides I have in which the trip distance was over 1,000 miles, which is a large number. So over 1,000 miles, we had in 2018 about 1 trip per day, which was over 1,000 miles, because 1,000 miles is going to be an expensive taxi ride in New York. So I can explore data. I can do absolutely anything I want to do with the data without moving it from S3. So I only had to point the data lake to my data. The data lake makes sense of the data, and I can already query it. But if I go to my boss and I say, hey, boss, this is the analysis I did. My boss is going to tell me, well, this is just numbers and queries. It's not really analytics unless you have some kind of business dashboard. So if you want to run any business dashboard, any analytics, you can actually use something called Quicksite. And Quicksite allows you to create dashboards on top of your data. So let me just show you for a second how this works. Okay, I'm not interested in what's new. So before I start dealing with the data, I need to actually connect the data set, because I never worked with this data set before. It's the first time I'm using it. So I'm going to create a data which is coming from Athena. I'm going to call this Colombo taxi, for example. And it's asking me in Athena which database I'm going to be using. I'm going to be using the 00 Colombo database. And which table? I only have one here. Okay. So I can just click here and preview the data. And once I could add calculated fields, I could add filters, I could add custom queries. Once I'm happy, I just click on visualize. So once I have a query, once I have a visualization, I just drag and drop to create graphics. For example, here I can say things like, okay, based on the pickup date, just build me a graphic of how many records by pickup date time. And of course, I can do this as complex as you want. I have multiple type of graphs. I can select the one I want, or just let Quicksite to select the one I want. I can add filters. I can add many different things. And here I can see I have an issue, because even if the data set is only for 2018, I can see I have some data which is not well cataloged. For example, I have data that is mistakenly coming from 2003 when the system was not in place. So I will need to clean up this data set. Ideally, I will do this before ingesting the data, because it's a data validation problem. But if I want to have self-service, I can just do it here. I can just tell Quicksite that I want to work only with data which is between January 1st, February 1st, I don't care. February 1st, 2018, and October 2018, for example, okay? So I apply my condition, oh, sorry, October 2018, yeah. So I apply my condition, and now I should be able to see the data, yeah, in a bit better way. And I could do interesting things. For example, if I want to add machine learning insights, I can do it directly from here. I can just add a machine learning generated forecast. In this case, it's telling me the prediction for the next 14 days based on the past observations. I can just ask for, no, I want to see the next 3 weeks of data, for example. So it's going to give me the prediction, the forecast based on this. And I can actually connect the Quicksite with any model running machine learning on SageMaker. So directly from the dashboard, I can connect with machine learning without having to do anything, which I believe it's interesting. The last thing I'm going to show you in the demo, because at this moment, I only catalog data, I only query the data, and I only work with the data interactively. I could have chosen also to transform the data. Imagine you want to transform the data from CSV to a binary format like Marquette, for example, or you want to remove some columns, or you want to do some complex operations. You could create a transformation job, or something we released this month, you can actually create a transformation job in a totally visual way. So you can do this. You can tell Glue that you want to transform the data. Let me see, here it is. So I want to transform the data from a table on my catalog, and it's going to be the, sorry, that's not the one I want to do, from a table on my catalog to another table on my catalog. And it's going to ask me, which is the database I want to use. I want to use the database Colombo. I want to use the database, this table. And I want to do a transformation. For example, I want to remove this column and remove this column. And I want to, I want to change the name of this column is going to be called extra fair, for example. So you could do any transforms. And actually, the transforms can be of different ways. They can be simple mappings like this one, or you could actually add more interesting transforms, like, for example, select only a few fields, or do a join between two different data sets, or just split a data set into two different depending on the fields, or do a filter, or run any Python code to do a custom transformation. So you can do all these things visually. Once you are happy, you can actually see the script that is generated. And this job is going to be running in a serverless way, a schedule or on demand whenever you want to transform your data. So you can use the whole functionality to discover data, catalog data, query the data, working with a schema evolution, transforming data sets, and doing visualization. So that's kind of the demo I wanted to do. So you see, and by the way, if you want to see a bit nicer visualization, because this one, the one I did here is a bit boring, I want to show you one which is a bit nicer. I need to remember, let's see if I have it. This is the one. So a Spanish AWS partner, they created this visualization using Quicksite. So it's just for you to see. The dashboard I created was very ugly, very boring, because I was just doing an interactive demo. But you can actually create interesting dashboards. So this one is a dashboard, publicly accessible dashboard that was created by a partner with data about the COVID. And yeah, so this is the kind of thing. You can have filters if you want. You can have different kind of visualizations. You can have, you have interactivity in the map. You can drill down if you want. You can have multiple tabs for the, for the different visualizations you want to do. So it's not just as ugly as I showed you, but you can actually create things that are a bit more interesting. That's, that's what I just showed you. It's just you need time to do it, but you do everything in the graphical interface I showed you. So that's kind of the power you get to do analytics in a fully serverless way. You only pay for what you use with AWS. So with this, I want to move very quickly because I know I'm already on my, finishing my time. So this will be for doing a fully serverless analytic. If you want to do data transforms, I already showed you, you can use Glue for that. So that's okay. Athena is the service I showed you for doing interactive queries with SQL. And Quicksite is the service I showed you for doing reports. And what if you want to do not only serverless analytics? What if you want to do something a bit more powerful? What if you want to do something other than SQL queries and transforms? Well, if you have the need for doing very complex analytics, if you need something like Hadoop or Spark, you can actually use Amazon EMR, which is a managed Hadoop or managed Spark, and it gives you many different components that are integrated and ready to go. And it's not serverless, but it has auto-scaling and it's fully managed. So you don't have to worry about managing the components, but it's fully compatible with open source Hadoop. So if you want to use Hadoop, you can totally use it, and we release frequent versions of Hadoop. And if you are wondering if this scales, it really scales. People like Epic Games, the people behind Fortnite, they have over 125 active million players. And a couple of years ago at reInvent, our conference, they were telling how they use AWS for everything. So everything in Epic Games works on AWS, and they were presenting actually about their data lake and analytics. And they are doing this. For their analytics, they have two pipelines. One is for near real time, so they can get insights in seconds. And the other is for batch, for doing more meaningful analytics. In both of them are using EMR, so they manage Hadoop. And then from that, they go to, they use S3 as the data lake. In the real time, they use DynamoDB as the data lake. And then you can connect with different components. In these slides, you cannot see anything about Glue or lake formation because those services were not released 2 years ago when these slides were created. But I know they have been adding more components to their stack. But if it's working for Epic Games, over 120 million users per day, then it's probably going to be scaling for you. And if you want to do a more traditional data warehouse, we have also something called Amazon Redshift that allows you to work also with SQL queries, but it's not serverless. You create a cluster and you have a bit more control of the, of the CPUs and of the, machines themselves. And if you want to use a combination of Amazon Redshift, the data warehouse to do SQL queries, with a data lake, so you can query data that lives outside of the data lake, you can actually use something called, you can export the data, of course, to the data lake, and you can use something called Redshift Spectrum that allows you to query data from S3 and also from Redshift at the same time without having to ingest the data on the data lake. And this scales very, 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 very well. So if you are wondering how this works in terms of performance, we did this test. We imagine you have an exabyte of data. An exabyte of data, it's 1,000 petabytes of data. It's a large number. You probably don't have an exabyte of data. But imagine you have an exabyte of data and you want to run a complex query, joining 4 tables with a few filters, with a group by, and so on. Now, imagine you want to do this running open source, and you have a cluster of 1,000 CPUs. How long do you think it will take a cluster with Apache Hive, with open source, running a SQL query like this over an exabyte of data? How long do you think it will take? We did an estimate, and we estimate it will take about 5 years. And it's totally unfair because, no database is prepared for this kind of a scale. Here, the bottleneck is not really the power of the database. The bottleneck is having to move an exabyte of data through the network, which is a huge amount of data. So we tried this on a Spectrum when we announced it a few years ago. And this is the time it took. It took a Spectrum 150 seconds to scan the exabyte of data to run this query. And yeah, it was about $300, okay? Because you are scanning a lot of data. And it doesn't make sense for the business. You don't want to do a query over an exabyte of data. That doesn't make sense. But this is just for you to see that when you are moving to cloud, you can do things that were just impossible in the past. And that's kind of, I want to leave it here. I had a couple of slides in case you wanted to go deeper. But since I'm already over time, this is what I wanted to tell you. So basically, if you want to run, to create a data lake, let me just go to the summary I had here. This is the one. Okay, so this is the one I wanted to solve. So if you want to create a data lake, all you have to do is create the roles and the users, create the S3 bucket, register the bucket on the data lake, which is what I already showed you. Ingest the data with the crawler, which again, I show you how to do it. Query the data lake, and just use it any way you want. I did the demo in about 15 minutes. In real life, it will take longer because you need to write the crawler, you need to write the transformations, moving data over the network, it can take a while. So for a medium data lake, not if you are in the terabytes space, it's going to take about a few days just to build a data lake starting from scratch, and you only pay for what you use. So that's kind of what I had. And yeah, if we have time and you have questions, I'm more than happy to take them. So yeah, thank you very much for being there.
Hi guys, it's up to you now to ask questions if you have any. Till others ask questions, I'll start with mine. Javier, can you share with your experience, what are the hard limits that we should be aware of when we start with data lakes?
How much money you have in your account? That's a hard limit you have there. You don't really, the cool thing about, and I'm kind of kidding, but not really, because your data lake, in effect, is S3. And as you know, S3 can scale really as much as you want. So the limit you have to be thinking is like the limits of what makes sense for the business. So it's not about what's possible, it's about what makes sense for the business. But with using just S3, you can scan petabytes of data in a few seconds. And no business need to scan more than a petabyte of data in one query. Actually, you usually don't go on a petabyte of data. I was once working, before joining AWS, I was working with a very large retailer, European retailer, very large, I believe the largest in Europe. And storing all the click streams of all the users across 19 different countries for, I believe it was for 4 years. That was about a petabyte of data. And you usually don't run a query that spans 4 years and 19 countries. It doesn't make sense. So what I mean here is that from the technical point of view, there is not really a limit that you are going to be reaching when you are working with a data lake. So it's more like from the business point of view, which data makes sense to have on the database, how you are going to be using it. And of course, it's very important to choose the right format for the data. Since on S3 you are paying for how much data you are scanning, if you put the data on CSV, as I just did, that data is going to be very expensive to scan. If you convert the data to something like Parquet, for example, when you convert data to Parquet, you are going to be using only a small amount of the data. So you can do queries that are orders of magnitude cheaper just by choosing the right data format. So something you could do, when I was showing you the example for transforming data here on the studio, something you can do when you are defining the destination of the, let me see if I can find here. When you are choosing the destination, you can actually tell directly, I want to convert to Parquet using gzip compression. And this is going to be much cheaper to store and much cheaper to query. So that will be my main recommendation, is to make sure that first you think about which data you want to keep, because maybe you don't want to keep all the data. Second, make sure when you ingest the data, you convert the data so you are not using JSON or CSV. You convert the data to something that makes sense, like Parquet, which is binary and it compressed very well. And also when you query by column, it's cheaper to query on Parquet than to query with CSV or with JSON. And I will also recommend you to take advantage of S3 capabilities to span multiple tiers. So put the old data, the one that you are not querying usually, move it to Glacier, and the data that is more recent, just put it on S3, maybe infrequent access, or just use the intelligence tiering on S3, so you can always be more efficient about how you are spending. But really, there are no limits how much data you can query. It's only a matter of efficiency on cost and on performance.
Amazing. Thank you, Javier. Guys, if you have any other question, please unmute yourself and ask. We'll have a few seconds. Okay, it seems people don't have questions at the moment. If you have,
I see one from Kamindo.
All right.
Yeah, so I see one from Kamindo. How to partition data on a database. So for that, I'm going to refer you to Athena partitioning, which is actually so that's on the documentation, and it has good tips. So here you have, if you go to Athena and you just look in Athena for the partitions, it's going to tell you how to partition the data. And partitioning means when you are storing data on your database, let me just see if I have my S3 here. S3. What are you, S3? I cannot see you. With the new interface, I cannot find anything. But yeah. So let me just see here. So Athena. I believe here, yeah. So I'm going to show you this data set I have here. So when you partition data, you do things like this. You have a structure with multiple directories. So here you can see I have my data, and I have a folder 2020, which is the year. I have a folder 8 and 9 for August and September. And here I have one folder for the day, the 31 of the month, and in September I have the 1st of the month. So basically, when you partition data like this, when you are doing a query, if you are querying data by these columns, by the year or the month or the day, Athena or Hadoop is going to read only the subset of the data on that partition. So it's going to make your queries, again, much cheaper. So there are different strategies for partitioning data, and you can partition data, usually partition by the things that are frequent in your queries, like, for example, the year or the department or the country or the language. And you can use a hierarchy of partitioning. And we have also a different thing called bucketing on Athena, which is similar to partitioning, but slightly more efficient. So if you don't find enough information about partitioning data on Athena, Athena is based on an open source product, which is called Apache Presto. So anything that you read about Apache Presto and partitioning applies to Athena, because basically Athena and Apache Presto are the same thing. So Athena is based on open source, and everything you read for Apache Presto is also valid for Athena. There are a lot of articles on the internet about partitioning on Apache Presto, but basically from the documentation in Athena, you can also find it. Okay. And just to finish with this, I'm going to pass you. Let me see. I want to pass you a reference. I'm going to put it on the chat to a very, very interesting post about how to make your queries more efficient. I'm trying to find. So let me see for a second. Okay, so I wrote this in Spanish, but I'm linking to one. So this is my post, but it has here a post in English. This is the one. So this blog post, if you're interested in doing more efficient queries and partitioning, that's the most authoritative blog post you're going to find. It links to, oh, sorry, I sent that privately to someone. Sorry about that. Okay, that's in public. So that blog post, it has a lot of pointers, how to deal with query efficiency, with partitioning, with bucketing data, with compressing data, with things that are going to be your operations much cheaper.
Okay. We also have another question. Javier, if you can make a small answer, because we have to make time for Yasdan.
Sure, sure, yeah. So Fernando, you're asking about how to deal with multi-tenant data. You can deal with that. That's simple enough. So basically, when you are working with data lakes on AWS, you can have strategies. You can divide data by accounts. So you can have multiple accounts and still have a single data lake. And then you can use permissions as usual on AWS. You can, for example, add permission by tags. So only some users can access to some tables from one account. So you can do that kind of thing. And so from Athena and S3 point of view, you will deal in the same way you use usually, either separating by different accounts or separating by tag and then adding security. And with Quicksite, it was not possible in the past, but I believe this was released in August. But now Quicksite have multi-tenancy out of the box, and that was announced. Oh, I thought it was August. It was actually end of July. But if you search in the big data blog on AWS, by the end of July, you have this article, which is when we released multi-tenant analytics directly on Quicksite. So you have there all the information. I'm going to pass that on the chat. Okay, so you can take a look.
Okay. Thank you very much, Javier. So if anyone else have questions, Javier is pretty active in Twitter. You can tag him on a post. He will make sure to answer. With that, I want to thank you for your time.